Hello, everyone, and welcome back to your channel of basic engineering. Last time we started analyzing trusses by using the method of joints, but we didn't get to do more than one example. So today I want to do another example. And before that, I want to talk a little bit about zero force members. I give you cases where we can find the zero force members. And all what you have to understand here is that there are only two scenarios where you can find zero force member. The first one is that if you have a joint with exactly three concurrent forces. What do I mean by a force? A force can be a support reaction. It can be a force in a member, or it can be an external force. Okay, any of those I am referring to as a force. So the first condition is that I have a joint that has exactly three forces. For example, B is a pin, so I have AX, AY, or BX, BY, force 2, so they are 4. So I'm not going to consider B. A is a roller. It has 1, 2, 3, 4, 5. 4 members and a reaction. So these are 5. 1, 2, 3. Yes, E has 3. D, 1, 2, 3. Yes, it has 3. C, 1, 2, 3. Yes, it has 3. So those three joints, C, D, and E, they have 3 concurrent forces. Okay. And that's the second condition. So the first condition, they are exactly 3, not 4, not 5, just 3. The second condition, and 2 of them are collinear. They have the same line of action. Well, at E, I have one horizontal, one vertical, one inclined. Now, not two of them have the same line of action. At D, I have one. Yes, these two are collinear, and that's the third. At C, there are two collinear. So C and D are candidates so far. Then the third, which is not the two collinear, the third is a zero force member, ZFM for short. So at joint C, I have CD, CB, CA. CD and CB are collinear, so the third one is a zero force member. At D, DE, CD, and AD, 3 of them, 2 of them are collinear, the third is 0. So these are zero force members. They are not carrying any load. And someone would say, if they are not carrying any load, so why do you build them? 2 reasons. The first reason is the rigidity of the truss. Suppose I take these 2 out. Do you see that this truss is rigid? I have pins here. That's the first reason. So I'm adding rigidity to my truss. The second most important thing is that this is a snapshot. I came at this point in time and there is a force P at E. What if like 2 hours ago, later, I see a force, say vertical or horizontal or even inclined at D? Who's going to carry that? Let's assume I have a force that is perpendicular to BCDE here. Isn't AD is the member that will carry that force? So it's no longer a zero force member. Same thing if I have say a vertical force or a horizontal or an inclined force at C, who's going to carry that? Okay, it would be this force. So that's the first thing you have to understand. Zero force members, it doesn't mean they are not needed. They are needed for rigidity. They are needed in another case scenario. Again, I've seen it too many times, as I always say. Students would say, AC is a zero force member because, which is correct. And then they go to A and they say, oh, wait a second. Here I have AX, which is the reaction at the support. I have 2, 3, 4, 5. No, it couldn't be a zero force member because I don't have exactly 3 here. There are 5. Say, yeah, I don't care. You can't prove or disprove it's a zero force member from the left hand side. You have, if you can establish that on one side, then don't worry about the other. You will never have a case where it you prove it's zero force from here and from the other end. It won't happen. Okay? So once you find out that at C and at D there are 3 forces, meaning in this case 3 members, and 2 of them are collinear, then the third is 0. That's it. Don't worry about the other end. So that's the first scenario. I told you there are only 2 scenarios. Now, let's come here. If you have a joint, so if you have a joint with exactly 2 concurrent forces. In this case, they have to be members. Then both are zero force members. So easy. There are only 2 here, so there are zero force members. How do you prove that? Well, you don't need to prove it, but take the forces, draw the free body diagram of the joint at D. There is a DE and a CD. Okay? Now, take the summation of the forces in the x direction. DE cosine this angle equals 0. So DE has to be 0. How come DE cosine something is 0 and the angle is not 90 degrees? So DE has to be 0. And if DE is 0, now take the sum of the forces in the y. Negative CD equals 0, so CD is 0. Okay, so that's an easy case. Also here I have at A, the vertical and horizontal forces. They don't have to be perpendicular. These are inclined. Like they have an angle between them that is not 90 degrees. But again, some of the forces in the x equals 0, some of the forces in the y equals 0. Both are zero force members. Okay, so that's basically what I wanted to go over before solving the second example using the method of joints, because we only had one. Well, not unfortunately, but this one doesn't have zero force members. Let's draw, by the way, before I continue, here I have 2 observations. If you look at this truss, the first observation is that I really don't have to start with the overall equilibrium of the truss. The reason being, I can start at D. D has only 2 unknowns, and I have 2 equations of equilibrium. I can find those. In fact, I can even find force in CE. It's 900 Newton compression. I don't need to worry about. But just because it's the norm, let's consider the free body diagram of the whole truss. So let me draw it here. Probably I have to use another paper because we have too many equations to solve here. Again, we are not drawing it to scale, but it's important to show all the needed information here. I have a pin at A, so I may have AX and AY. I have also a pin at B. We haven't seen this case before. Where you have, oh, I'm sorry. I shouldn't draw that. No, we don't draw it. We are taking it away and replacing it by the reaction. It's not correct to draw the support as well as the reaction because there are two forces. These are internal forces. They come in pairs. You only see one of them when you take away the truss from the pin. I think this would mess it up. It didn't. So I don't need to do that. You just say AX and AY, BX and BY. Okay, you don't draw the support. Of course, I have dimensions that have to show. So I have, this is 4 meter. This is 4 meters. This is 6, even though it's not, it doesn't show like it's 6. And these angles, okay, we can say that also this split it into 3 and 3. This is half the distance, so this is also half the base, so this is 3. Why do I do that? Because I'm telling you that these two members and that one, they're inclined 3, 4, 5. They don't give you the angle, but you can use the slope. Same thing for this guy. Vertical is 4, horizontal is 3, inclined is 5. Here is my x, here is my y. Since you are going to use them, then you have to show what do you mean by x and y. Later, you will see that, as I said, sometimes we use an inclined plane as the x and the normal to it as the y. So x and y are not necessarily horizontal and vertical. And here I'm showing everything. The only thing I'm missing are the letters. See, no, not only, also the external forces. Last time we saw that I always assume tension. If I end up with positive, it's tension. If I end up with negative, it's compression. But sometimes you can do better. For example, if you look at D, do you see that the external force is going to the left? So the internal force, you shouldn't draw it, by the way. It's not correct. I'm drawing it just for purpose of illustration. Then this arrow here, do you think it's going down or up? If you say going down, then its horizontal component is to the left. So external to the left, internal to the left, this truss would tip over. So that definitely has to be going up. And if it's going up from here so that the x cancels the 600, then it's vertical, it's going up. So the vertical of this guy is going down and up from here. And if this is going up here, then it's going down there. And you can keep going. Sometimes you cannot find everything. But for example, I have 900 going to the left. So this must be going to the right. On the other side, it's going to the left. This is going up, so this is going down. And if this is going down, this is going up. BY, we don't know if BY is going up or down. So after that, maybe we cannot say what happens, okay? But sometimes when you know how it goes, it might be easy just to figure out that, first of all, if these two forces are pushing the truss, excuse me, if you think that this truss is made of a rubber, for example, don't you see that if I try to push this rubber to the left and it's held here, that these two members would be stretched out? Yes, they are under tension. The arrow is going away from the pin, meaning it's under tension, and these two would be under compression. If I'm turning, if I'm pushing this, it's stretched here, so this would be also compression. Again, you don't have to do that. But later you just will look at the truss and try and be able to figure out what each member is. But having said that, let's go back and check for, remember before that, or last time I told you, the equation that we used to check the stability and the determinacy of a truss was 2j are the number of equations I can write if I have j joints. And that should equal m, which is the number of members plus 3. Why did we say 3? Because we said usually for a truss to be statically determinant, I will have a hinge or a pin on one side and a roller on the other. But look here what we have. We have a hinge or a pin on the left and a pin on the right. I have 4, not 3. Does that mean that my truss is statically indeterminate and I cannot find all the forces and all the reactions in it? No. Why? Let's correct this. This would be written like that in pretty much all analysis textbooks, but the correct way to say it is 2j equals m plus r, where r are the reactions, the number of total reactions at the support. So in this case, 2j, I have A, B, C, D, E, 5. 2 times 5 is 10. I have 4 reactions at the support, so I may have 6. If I have 6 members, then I'm fine. If I have 5, this truss is unstable. If I have 7, it's statically indeterminate. So please correct that. We said before m plus 3. The correct one is to say m plus r, and most of the problems you will encounter, r would be 3, but not always. 1 member, 2 members, 3 members, 4, 5, 6. So it's statically determinate. Okay, now considering the overall equilibrium of the truss, so free body that we already drew the free body diagram of the truss, I can take the moment about A. Summation of the moment about A equals 0. And some people say counterclockwise is positive, just to show that you don't have to. So 600 is rotating counterclockwise, meaning positive moment 600, and the vertical distance is 8. The 900 is also rotating clockwise, so it's plus 900, but the distance now is 4. It's midway. And then the BY is also rotating, cannot be, right? But the distance is 6. So we know that BY is negative. We get 6 BY equals negative 4,800 minus 3,600 equals negative 8,400 Newton. Dividing by 6, get BY is negative 1,400 Newton equals 1,400 Newton. I drew it incorrectly. It should be going down. Then I can, since I did that, I can say sum of the forces in the y equals 0, and some people do this. I usually don't, but it's sometimes to say I'm going to assume anything going up is positive and anything going down is negative. I have AY is going up, BY is going down, so minus BY, which is 1,400, equals 0, so AY equals 1,400 Newton. Positive meaning I drew it correctly, it's going up. That's it. You can't find AX and BX. I've seen students say, oh, they must be equal 0. No, they don't. But we cannot. Why can't we? Because we only have 3 equations of equilibrium for a rigid body. We use 2. I only have 1. How can you find both AX and BX if you have 1 equation? That's funny. It reminds me of something when you were a kid and say, you take fill in the blanks question. So let's say your teacher gave you 10 sentences with 10 blanks and 10 words. You can get them all right and get 10 out of 10, but you can never get 9 out of 10, right? If 9 are correct, then the last one has to fit unless you forgot to fill it up. But I'm saying if you fill all 10 different words, you can either get 8, 7, whatever. You can get from 0 to 8, but never 9. This is something similar. You can find 2, but never 3. Why? Because there are 4 unknowns and only 3 equations of equilibrium. So anyway, has nothing to do with the fill in the blanks, but it just occurred to me. It's funny. Anyway, so your son cannot get 90, cannot get an A, either get full mark or get B. And you say, why? Why did you get 2 wrong? Anyway, so let's see. Now, since I know the AY and the BY, notice as we said, D has only 2 unknowns, right? I can start with D right away. I can draw the free body diagram of joint D. And the way we do it, here is point D. I have an external force of 600 Newton going to the left. As I said, if it's going to the left, then the force DE has to be going up so that when I find its reaction, I'm sorry, its horizontal component, it has to be going to the right. So I know that force DE is compression. You can still assume it's tension, and then you say, oh, I ended up with a negative sign, so it's compression. Some students, unfortunately, have in their mind positive is tension, negative is compression. No. Positive meaning you drew it correctly. Negative means you drew it in the opposite sense. So if you think about it and you say, oh, this thing is going to turn, it's going to compress DE, so DE is compression, you draw the arrow going into the joint, you will end up with DE being positive. Positive meaning, yes, my expectation was correct. It is compression. So please don't confuse positive and negative. Positive and negative meaning correctly drawn, incorrectly drawn, not tension or compression, unless you always assume it's tension. If you always draw the arrows going away from the pin, then of course positive mean tension, which again means you drew it correctly, and negative would mean compression, which means also that you drew it incorrectly. These are 2 different things. Don't confuse them. And then I assume CD also is tension going down, which I know for sure it is. And here is my X, here is my Y. I'm going to use summation of the forces in the X and Y, so I have to draw them on my free body diagram. You see, I have a free body diagram for the truss, as well as a free body diagram for each joint. It doesn't make sense to start with the Y because I have 2 unknown forces in the Y. But if I say summation of the forces in the X equals 0, and as I said, some people do this, then I have the slope, we said it's 3, 4, 5, meaning 3/5 of DE is positive going to the right, minus 600 is going to the left. So DE would equal 600 times 5 over 3, which is 1,000 Newton, meaning 1 kilonewton. Positive meaning compression, not tension, because I assumed it was compression. Then I do summation of the forces in the Y equals 0. DE is going up, so 4/5 of DE is going up. CD, I assume it's tension, minus CD going down equals 0. So CD equals 1,000 times 4/5 or 800 Newton. I assumed it correctly, so it is tension. So now I found this force, I found that force. Next joint is trivial. If you were solving it for yourself, so you are not, that wasn't a homework or a test, it's just you were trying to do something, you don't need to do anything, right? You can look at it and see exactly what's going on. Free body diagram of joint C. Here is joint C. I have force DE that I assumed it was tension, and it is really tension. That's 800 Newton. I have 900 Newton going to the left. That's an external force. I know for sure that CE would be under compression, because if this is going to the left, then CE would be going to the right, going into the pin. And if this is 800 going up, then BC is 800 going down, but we are going to write it DC. Again, here is my X, here is my Y. It doesn't matter what you start with. Summation of the forces in the X equals 0. I have CE minus 900 equals 0. So CE positive, meaning compression, because I assumed it's going into the pin. It's compression, and that's CE. Sum of the forces in the Y equals 0. Again, Y up is positive. I have 800 going up minus BC going down equals 0. So BC equals 800 Newton. I assumed it's tension. I got positive, so it is tension. So now I found this guy. I found that guy. I can move to joint B. Notice at joint B, I have two unknowns. Say, where is that? Yeah, I have B. I'm sorry. I have BX, which is not known, and I have BE. So I have two unknowns, like I said. Okay, so let's say free body diagram of joint B. Here is B. I have the reaction BY. It was going down 1400 Newton. I have BE. Oh, first of all, I have BC. It's tension, so it's going up 800 Newton. Notice, so these two, the resultant is 600 going down. So BE must be going up, or else who's going to take the difference? So I'm going to assume it's tension again, 3, 4, 5, and this is BE. And finally, if this is going to the left, BX is going to the right. Notice I have a reaction BX here. So I have two unknowns. One of them is a reaction, and one of them is a member force. Here is the X, here is the Y. I definitely will start with the Y because it's only one unknown, which is BE. If I start with the X, I have BX and BE. So I will get a relationship between two unknowns, but I cannot find their magnitude with one equation. I will have to solve two equations simultaneously, which I don't want to do. So summation of the forces in the Y equals 0. I have 4/5 of BE plus 800 minus 1400 equals 0. So 4/5 of BE equals 600, right? When you move that to the other side. Then you multiply by 5, you get 3000 over 4, you get BE equals 750 Newton. Positive, I assumed it's tension, so it is tension. Finally, at this joint, summation of the forces in the X equals 0. Again, this is positive, this is positive. What do I have in the X? I have BX going to the right minus 3/5 of BE, which is 750, going to the left. 750 over 5 is 150 times 3 is 450. So BX equals 450 Newton. Positive, meaning I drew it correctly. It is to the right. Notice, how many unknowns did we find so far? We find 1, 2, 3, 4, 5 members and three reactions at the support, so they are 8. I only have one more unknown. No, 2, right? two, but one of them is so easy. Remember here, we said we used the moment, we used the sum of the forces in the y, but we didn't use the sum of the forces in the x because we had two unknowns, but now we already know bx. Be careful. I'm going to say summation of the forces in the x equals 0 for the whole truss. What do I have? I have ax going to the right, so it's positive. Don't forget the external forces. Don't say it's 450 to the left. No, it's not 450 to the left because I have forces here, negative 600, negative 900, and positive 450. 600 and 900 is 1500. When you subtract 450, you get 1050. So AX is 1050 Newton, positive, meaning yes, it is to the right. Notice that 1050 and 450 is 1500, 600 and 900 is 1500, so they must be the same. Finally, the last thing we are going to do is to go to joint A. That's the only joint I have that free body diagram of joint A. Now, I found all four reaction components. I found 1, 2, 3, 4, 5, 9 unknowns, and I only have 10. But I have two equations of equilibrium at A. Huh, yes, yes. So what we are going to do is to use one of them to find the magnitude of the force in AE, which definitely has to be compression, right? We found that the BE was tension, meaning this is pulled away at E. Notice the component of this guy is going down, the component of that is going down, so AE must be going up, pushing the pins, so it's compression. And we knew that from the fact that if that has been like flexible, like rubber or something, then these two members inclined in this direction would be compression and the vertical members would be under tension. You don't have to know that, but it's something that you would learn. Next, I have two equations of equilibrium. So let me use one to find the magnitude of AE and the other one to check my answer. Is it correct or not? Right? You can use the X or the Y, it doesn't matter. So if I say summation of the forces in the X equals 0 at A, I have AX, which we just found as 1050 going to the right. And, oh, I didn't draw the, oh, sorry, so sorry. Here is B, here is A. There is AY is 1400 going up. AX is 1050 going to the right. And we know that AE is going down, the slope 3, 4 to 5 as usual. And this is my X, this is my Y, just to be complete. And we are going to say 1050 going to the right minus 3/5 of AE going to the left. 3 is the horizontal. So AE equals 1050 times 5 over 3. If you divide by 3, you get 350. You multiply 350 by 5, you get 1750 Newton, positive meaning tension. And now I'm done. I found all the forces in the truss and all the reactions at the support. Finally, as I said, I can use the last equation of equilibrium to check my answer. So check sum of the forces in the y direction equals 0. I have AY going up of magnitude 1400 minus 3/5 of AE, which I just found to be 1750. Oh, 50. Divide by 5, you get 3. Wait a second, did I wrote this correct? This is 4/5, right? Yeah, 4/5. I'm sorry. It's vertical. vertical 4. It's 3/5 for the horizontal. 1750 divided by 5 is 350. 350 times 4 is 1400, so I get 0. I checked my work. And I hope this was, I know it's too much, but at least this covers everything in using the method of joints in trusses. I want you to see that I have, like, we found that AY is 1400 up, 1400 down. That's a clockwise couple. 1400 times 6 is 8400. So I have a couple going like that contra or counters the two outside counterclockwise couples, 3600 and 4800, which they add up to positive 8400, and that's why my truss will not turn one way or another. Okay, thanks for your time. I know this was a slightly long session. I hope it wasn't that bad. And I hope we did everything correct. But if you have any question, please don't hesitate to comment on that, and I will get back as soon as I can. Next session, I will pick like 2 problems to solve with the method of sections, and we'll see the difference between the two and which one should I use. It depends, of course, on your experience. After you solve many problems, you'll see which one is more appropriate. Of course, if you are taking a course in statics, they will tell you use this method or that. Very few professors. I used to let my students take decide, but I always try to make a problem that is easier to solve with one method or the other. So if you pick the wrong one, you are penalized by using more time than needed. So I'm not going to take any points off, but you penalize yourselves. So I want you to understand how to select. This is important. It's not just about, memorization or following an example to the letter. Okay. Anyway, thanks for your time and wish you all the best, and I'll see you soon.